Hi, good morning. My name is Yuchi Huang. I'm from ACT Next. I'm a research scientist of machine learning group to conduct some research of machine learning and artificial intelligence for education. So today, the topic I'm going to discuss is a multimodal micro-content generation. So I believe everybody agrees that content is very important for the learning process. Good content can promote engagement, increase interaction, and also boost efficacy. But creating content is quite difficult, especially at scale. So what can we do? People may know that as introduced by Alina, ACT is transforming from a testing company to a learning and navigation company. So we acquired some companies like OpenNet and Novation. So OpenNet is an online library for video lectures, and Novation is a company focusing on curated learning resources. So we have all these resources, and what if we want to integrate them and to provide to the students in a better way so we can better serve the customers? So what we can do? So our strategy is to utilize AI and machine learning to create micro, small form content from existing content. So people may ask why small or micro content? So let's take video lectures as an example. The first reason is that it can the engagement level is quite relevant to the length of videos. So from the figures on the left, you can see that shorter videos always has better engagement level. Is on the above. And another phenomenon is that throughout the playback of one video, no matter what it's long or short, so the engagement level will decrease throughout the playback. Another reason is efficacy. And if we know exactly a student want to learn, so we can navigate or direct him or her to the position or the segment of a video directly, so this can save her or his time.
So just to amplify your point, Yuchi, the curve that you showed on engagement goes down like this.
Mm-hmm.
Efficacy, and I'll be talking about our efficacy analysis of
Yeah.
OpenAd videos. It's even stronger. It's a chi-square distribution.
Okay.
So the drop-off in
So more quickly.
is even more steep. So the efficacy thing, I think, makes it even more powerful argument for the video splitting that you're doing.
Great point. I'm not sure if you know or don't know. There are some very good video platforms which can provide very good mini micro content videos, such as for vocabulary. They create some kind of like hip hop styles of for different kinds of video lectures like history, science, and I'm not sure whether I can play for this. No, I cannot. So this is basically a video. So let me skip this. The framework of our project is like this. So we have long form videos ranging from like 10, 20 minutes to an hour, something like that. And we perform video segmentation algorithms to chop them into small pieces we call atomic construct video clips. And each of them is for only one small knowledge point or skill. And at last, if we know the performance data of students, or we know the needs of students by the entry of students themselves, we can deliver those contents in countless combination of them. So this is a very simple example. Think about, we have two videos. One is about animals of Africa, and another one is natural scenery of Africa. And we chop these videos by the video features and the thematic features into atomic clips. And if we want a video, for example, Wild Africa, we can automatically select different parts of the clips from those above two videos and combine them to a video which is called Wild Africa by some visual effect alignment and semantic ordering. To do this, we have to employ some machine learning methods and features. So here I listed some possible modules and features we are using and we are going to use. For example, if we have videos, and what we do is that we have transcribed captions, and we have acoustic features, basically speech or music from the videos, and we have visual information. So what we do is that from the captions, we can extract keywords by LDA, and we can get some vectorized features, for example, dot to vector or word to vector to get some like semantic information. And we can also extract deep learning features from speech information and also from visual information and combine all this together to form a big feature pool and throw them into neural networks, different kinds of them, and to do, for example, video segmentation and other tasks. And after we have video clips, so after we have all kinds of features, another topic, another task we can perform is content tagging, and I will show how we will do this later. And in this slide, I will introduce the actual algorithm we are using to conduct the video segmentation. Suppose that, for example, we have a video having only like 6 sentences. We're trying to find one segmentation point in this video. So, I mean, the very straightforward organization method is that we consider that the whole video is a sequence of sentences of captions. So we're trying to find a video, segmentation point from these like 5 positions. So what we do is that we extract features from each of these sentences. For example, for each sentence, we can extract the word to vector information or sentence embedding vectors. We can also have visual frames and the sections of speech or music, and we combine this all information together and input them into a recurrent network to predict the probability of segmentation at each point, at each ending point of the sentences. And to conduct this research, we also need some data sets, and we don't have it. So instead of selecting long-form videos and hire people to annotate those videos, which point is segmentable, what we did is we use existing Khan Academy videos, because we found out Khan Academy videos are very well segmented. And the only difficult part is how can we find which videos are coming from the same recording group. That is, originally they came from which long-form video. So what we do is that we use a visual similarity feature. That is, we found out if 2 videos, they came from one same recorded video. So basically, the last frame of that video is very similar to the first frame of another video. For example, these 2 videos are 2 short videos of Khan Academy Math. They are both about shared methods, and the first frame is the last frame of one video, and the second frame is the first frame of another video. So basically, if we measure the similarity between these frames, we can directly know that they came from the same recording videos. So in this slide, I provide some results, some plots of segmentable probabilities. The horizontal axis refers to the number of sentences of 2 videos, and we combine them together. And the vertical line, the vertical axis is the probability, and the blue line refers to the segmentable probabilities of all the sentences, and the red lines are the ground truths. So we can say that, if we only rely on the text information, this makes sense. Although it contains some errors, that is, there are some local maximums which are not ground truths. But if we combine some visual features such as, for example, the optical flow between the frames, we can just eliminate those errors. And after we did do some video segmentations, so we can perform other tasks like video recommendations. See, we have done video segmentation, so we can extract features, semantic features, and topic information from those clips. And we can do evaluation on the learners on their performance data by the items related to this video. And in this way, we can recommend relevant videos targeted to this student only. And we can also utilize visual recognition information, because we know that, for example, what videos have been reviewed by these students, and we can search only those videos contains the similar visual information and deliver them to the students. And another task we are trying to do next is tagging of holistic framework labels. And I'm not sure whether you know ACT holistic framework is a holistic standard of different domains for the success of students, for their academic success, and also for their work readiness. So it's a very long coding system. You can see that, for example, this long coding, h.a.math.gm.3df. So each word, for example, the GM means geometry and measurement, and 3df means 3-dimensional figures, and something like that. So it's kind of a tree structure framework. So if we can automatically align this framework to the items such as books, handouts, video lectures, then it will be very useful for us to do the navigation recommendation. So what we have right now is we have holistic framework descriptions, and we have some very small number of content labeled. So maybe in the next step, we are going to perform some like semi-supervised learning on that, and to automatically label the content we have. Item content, yeah, and videos and other stuff like. Yeah, yeah, I know. Yeah. So, yeah. So basically, this is the presentation. If you guys have any questions.
So we'll have questions. I'll just ask the speaker to please repeat the question, because we don't have another microphone.
Okay.
If you have a question, please stand up. Oh, we do have another microphone. Does it work?
Yeah.
All right, go on then.
Thank you. Just a comment. I would encourage you to think of this presentation in the context of what I presented earlier about the companion app, because they are related. I mean, this is part of the infrastructure that we use for the companion app as well, especially the tagging part of the holistic framework. So I didn't get a chance to talk about that, but this is definitely one of the parts.
Yeah.
This is kind of a two-part question. One, and I think you answered it by saying you get your videos from Khan Academy. So the question was about copyright issues, and so it sounds like they've made it free and available for use. But if you were to use the algorithm for a more widespread video on the web, you would need to address that issue. And the second part of my question is, it seems like at least the algorithm you discussed thus far is more focused on video as opposed to text or other forms of educational content. So if you could speak to that.
Okay, so this is a good question. Right now we are focusing on videos. Yes, because video segmentation and reorganize of the video is the most difficult part. And definitely we can also use a similar technology or algorithms on text information, for example, handouts. We can summarize, get a summarization from handouts and put them together in an order way and present this to students. Yes, definitely we can do that. And if later we have other form of educational content, we can do the same thing. Yeah.
Can I answer the other part about like fair use of video content?
Yeah.
So all of those videos that they're working on are on OpenEd, and those videos are aligned through machine learning to specific learning goals, but there's no like re-hosting of the videos, and those videos, almost all of them are hosted on YouTube, including cons, and part of putting your stuff on YouTube is you have to agree to a terms of service, and then we use the YouTube API to get all of the metadata, including the transcripts, to do the machine learning alignment. So there's no issue about use, and if you want to keep your video private, then don't put it on YouTube.
Yeah. And so let me introduce, this is Adam, the CEO of OpenNet. The company I mentioned, this is one acquisition made by ACT. So during the process of, the transformation from a testing company to a learning and navigation company. So because we have OpenNet, we have a stronger stand on learning and navigation.
We have time for one more question.
In your kind of first intro slide, you showed the difficulty of kind of creating good video content in some sense. Do you see any other challenges other than kind of you highlight in your talk here?
So I think because currently if we are creating contents, this has to be done by human being, and it's expensive, it's time consuming, and it depends on experts of domain, of specific domains. So it needs domain knowledge. To say that, so I would say creating content, original content is quite difficult. Yeah. So, but right now, by our algorithms, we don't create original contents. What we do is that we reorganize the content in a better way so can increase the engagement of students to increase the efficacy.